The background and the motivation, it was like for forecasting the stock market and time series, because they have a complex pattern, and like all old models and traditional models, they almost fail to recognize these long dependencies in time series due to their complexity, and like the day by day they get more complex because we have more data like feeding in each like stock market. And the problem started with, as I said, uh, with the non-linear and chaotic nature of financial time series, because like sometimes you should consider like the long-term years, like 4 years, 5 years. And traditional models, firstly they are slow, like support vector machine, SVM, or ARIMA. They are statistical models and techniques they've been used and still they are using in some parts of like for different kind of predictions, but they are not practical really like in like 2024. And yes, let's see the objectives we followed. The model is like hybrid model like created, is based on LSTM. It's LSTM, it's type of recurrent neural network or RNNs with the different cell design that you can watch it. You can see it exactly. I explained it in the paper article. And from the first model, that is LSTM, I will, let me go to methodology. From first LSTM, I will add up some information and weights. I will transfer it to the second part of phase of the learning, and it's like fine tuning it, like fine tuning. And both data are correlated. Is the S&P 500 and Nasdaq 100 stock market indexes, and they are like almost same because S&P 500 is like 500 top big market cap companies in the USA, like Google, Meta, and Nvidia, and the rest of them. And Nasdaq 100 is 100 top tech companies from that 500. That is mostly tech, like starts with Nvidia, it will go to Intel, Tesla, AMD, and the rest Google. So they are correlated, like because like the companies are same, and like the earnings of these companies, like tech companies, in the past years are higher, so they have a bigger weights even in the S&P 500. So the data was like had this columns: open, high, low, close volume, and adjusted close daily return. So what I did, I consider all of them for the input. My output was close, because like the price, it was my target price. Also, I calculated daily returns, but by subtracting like the previous day and the today's close, so we can understand like how was like the daily return like in the day when you bought the stock, one stock. After data cleaning and like missing handling the missing data, I feed them to my neural network and LSTMs. So as I said, we had like two LSTMs. First one for training for Nasdaq, for S&P, and applying fine tuning it on the Nasdaq for the second one. And it includes like 50 hidden layers for each LSTM. And I used dropout due to like I didn't want to overfit the model. It's like 20% is like the standard I put. Then the output there is with with the linear activation functions is relo I used. And let's see the results. And sorry, training, during the training. The source was like pre-training, as I said, on the S&P 500, then fine-tuning it with the very low like level, like 0.001. I fine-tuned it on the second LSTM because I didn't want too much data. Like I didn't want it exactly like 80%, 50%, I apply all the weights. So I use like smaller measures, so it's more realistic. And for my evaluation metrics, I use mean absolute error, mean square error, round root mean square error, and MAPIP. And for the results, we can see, yes, here. As a result, like we can see, like the prediction and accuracy was not bad actually, and it was close. And like in financial forecasting, time series and financial market is almost impossible, like to get like 100% or 90% accuracy, because like they are impossible almost to forecast, like because there is a many macroeconomic uh, in the effects, so we cannot predict that one. So this is based on like numbers, statistics, and the candles, like the closing and opening. But the accuracy, it was good. Like I tested this. This is for like 2 weeks. I separated from my old data set last 2 weeks for test and validation, and we can see it's not bad actually, because like the stocks I used, they were like almost correlated. Like the correlation is very high between them. So that's why it's effective. Like in the transfer learning, finding like most correlated stocks and indexes is like the most important thing, I think, because you can leverage it in the model, and like they will use less and the model will run faster, and they will use less hyper parameters if they are correlated. So yes, like as I said, like the results were good. Although like 100%, 95%, 90% accuracy is like far beyond still. You need more complex models. You need maybe sentiment analysis models next to this. You will get like a higher accuracy. And yes, for future work and conclusion, as I said, like they are effective hybrid models. Finding the most related indexes and like inputs is important due to they will get complex. But as much you feed data to the model and different kind of indexes, if you find, it's better, much better. And real-time data integration is very important. Unfortunately, I didn't have like the opportunity to do it, but I think it's easy. You can get the API from one index and like apply it in the Python in the real time, like for the model, but like the model should run. Thank you everyone for watching. If you have any questions and answers, please comment, and thank you so much.